Today I am going to talk about lattice point and space lattice. A crystal is solid composed of atom or other microscopic particles arranged in an ordinary lattice array. The arrangement in a crystal is crystal structure. In a perfect crystal, there is a regular arrangement of atoms. This periodicity in the arrangement generally varies in different directions. It is convenient to imagine point in space about which these atoms are located. Such points in space are called the lattice point, and totality of such points form a crystal lattice or space lattice. If all the atoms at the lattice point are identical, the lattice is called Bravais lattice. About, let us consider the case of a fundamental array of points as shown in this figure. तो पहला ये array of point है जिसमें दो वेक्टर r1 and r2 are connected to a point O. So their difference will be t, which is equal to n1 a1 plus n2 b. N1 and N2 are integer and A and B are the fundamental translational vector characteristic of the array. Then the array of the point is a two-dimensional lattice. In three-dimensional it will be N1 A, N2 B and N3 C. Hence, a crystal lattice refers to the geometry of a set of points in space, whereas the structure of crystal refers to the actual ordering of its constituent ion atom molecule in the space. For a lattice to represent a crystal structure, every lattice point with one or more atoms are called the basis. Every lattice point with one or more atom is called basis or pattern. When the basis is repeated with the correct periodicity in all directions, it gives the actual crystal structure. The crystal is real while the lattice is imaginary. So lattice, this full figure you see, it is lattice. 3 molecule का केस है तो 3 atom का केस है तो this is basis और इस दोनों का sum is equal to crystal structure. In crystalline solid like copper and sodium, the basis is a single atom. In NaCl and CaCl, the basis is diatomic. In the crystal like calcium fluoride, the basis is triatomic. Next जो आता है वो आता है term, basically आज definition पे ज़्यादा ही हम concentrate कर रहे हैं. Unit cell and lattice parameter. The atomic order in a crystalline solid indicate that a small group of atoms form a repetitive pattern. It is convenient to subdivide the structure into small repeating identities, that is, unit cell. And every crystal, some fundamental grouping of the particle is repeated. मतलब क्या हुआ कि जो स्मॉल पोर्शन कंटिन्यूअसली और पीरियडिकली रिपीट हो रहा है, that small portion will be called unit cell and group of the unit cell जो है वो आपका क्रिस्टल बनाता है. Unit cells for most of the crystal are parallelepiped or cube, having three sets of parallel faces. A unit cell is chosen to represent the symmetry of crystal structure, wherein all the atom position in the crystal may be generated by translation of unit cell. यूनिट सेल है तो वो उसकी रिपीटिशन होगा, that is the translation of through integral distance along each of its edges. The unit cell is the basic structural unit or building block of the crystal structure by virtue of its geometry and atomic position within. A unit cell is a three-dimensional crystal lattice. A space lattice is a regular distribution of points in space in such a manner that every point has identical surroundings. The lattice is made up of a repetitive unit of unit cell. A unit cell can be completely described by three vectors A, B, C with the length of the vector and the angle between them is alpha, beta, gamma are specified. ये समझ लीजिए ये स्ट्रक्चर है तो लेंथ जो है that is ABC and angle between these ABC is alpha, beta, gamma. Taking any lattice point as origin, all other points on the lattice can be obtained by a repeated operation of lattice vector ABC. These lattice vector and above said interfacial angle constitute a lattice parameter of unit cell. If the value of this intercept and interfacial angle are known, we can easily determine the form and actual size of the unit cell. The vector ABC may or may not be equal. The angle alpha, beta, gamma may or may not be a right angle. Based on this condition, there are several different crystal systems. समझ में आई कि नहीं? ABC बराबर भी हो सकता है, बराबर नहीं हो सकता. अल्फा बीटा गामा राइट एंगल फॉर्म कर सकता है, नहीं भी कर सकता है, और इसके आधार पर 7 डिफरेंट क्रिस्टल सिस्टम किया गया है. If atoms are existing only at corner of the unit cell, the 7 crystal system will yield 7 type of lattice. Browse shows that the total number of different space lattice type is only 14. Browse lattice refer to the 14 different three-dimensional configuration into which atom can be arranged in a crystal. The smallest group of symmetrically assigned atom which can be repeated in an array to make up the entire crystal is called a unit cell. यहाँ पे एक नया डिफिनेशन आता है प्रिमिटिव सेल. यूनिट सेल एंड प्रिमिटिव सेल दोनों एक मायने में एक हैं, एक मायने में अलग हैं. तो जनरली 2 नंबर का क्वेश्चन पूछा जाता है कि यूनिट सेल और प्रिमिटिव सेल में क्या डिफरेंस है. तो प्रिमिटिव सेल का डिफिनेशन क्या है? प्रिमिटिव सेल में बी डिफाइंड एज जियोमेट्रिकल शेप which means repeated indefinitely in 3 dimensions will fill all the space and is equivalent of one lattice point. इसका मतलब क्या हुआ? The unit sheet that contain one lattice point only at the corner is known as primitive cell. बस समझ में आया नहीं? The unit cell contain one lattice point only at the corner is known as primitive cell. The unit cell differ from the primitive cell is that it is not restricted to being equivalent to one lattice point. Unit cell may have more than one lattice point. इसका मतलब क्या हुआ? Unit cell may be primitive. If one lattice point है, it is primitive cell. But all primitive cell need not be unit cell. अगर क्वेश्चन आता है 2 नंबर का तो आपको ये पूरा तीनों पॉइंट लिखने पड़ेंगे. उसके बाद 7 की हमने बात की थी. There are 32 class of crystal system based on the geometrical consideration. In common, it is divided into 7 groups or basic system. The basic crystal systems are cubic, जिसको आइसोमेरिक भी कहा जाता है, टेट्रागोनल, ऑर्थोगोनल, मोनोक्लिनिक, ट्राइक्लिनिक, ट्राइगोनल, जिसको रोम्बोहेड्रल भी कहा जाता है, एंड हेक्सागोनल. लेट्स आइडिया लिया जाए ये जो बेसिक क्रिस्टल सिस्टम से वो क्या है. तो क्यूबिक क्रिस्टल सिस्टम में क्या होता है? A इज इक्वल टू B इज इक्वल टू C, अल्फा बीटा गामा इज इक्वल टू 90 डिग्री. ऑलमोस्ट क्यूब टाइप का चीज हो गया ये तो. Crystal axes are perpendicular to one another and the repetitive interval is same along all the 3 axes. Cubic lattice may be simple, body centered or the face centered. ये सिंपल, बॉडी सेंटर एंड फेस सेंटर नेक्स्ट क्लास में हम बताएंगे क्या होता है. अभी से पे जान जाइए क्यूबिक लेटिस जो है सो 3 तरह के कॉम्बिनेशन में पाया जा सकता है. ट्राइगोनल क्रिस्टल सिस्टम में A इज इक्वल टू B बट नॉट इक्वल टू C. अल्फा बीटा गामा is equal to 90 degree. And the crystal axes are perpendicular to one another. The repetitive interval along 2 axes are the same, but the interval along the third axis is different. ये कहाँ पाया जा सकता है? सिंपल टाइप ऑफ क्रिस्टल में या बॉडी सेंटर क्रिस्टल में. ऑर्थोरोम्बिक क्रिस्टल सिस्टम में A is not equal to B is not equal to C, alpha beta gamma is equal to 90 degree. The crystal axes are perpendicular to one another, but the repetitive intervals are different along all the 3 sides. ऑर्थोरोम्बिक लेडीज का जो बेसिक कहाँ पाया जा सकता है? सिंपल, बेस सेंटर्ड, बॉडी सेंटर्ड एंड फेस सेंटर्ड. Fourth one is monoclinic crystal system. जिसमें क्या होता है? A is not equal to B is not equal to C. Alpha is equal to beta is equal to 90 degree and gamma is not 90 degree. मतलब 2 crystal axes are perpendicular to each other, but third is obliquely inclined. The repetitive interval are different along all the 3 axes. ये पाया जाता है सिंपल एंड बेस सेंटर क्रिस्टल में. ट्राइक्लिनिक crystal system, A is not equal to B is not equal to C. Alpha, beta, gamma are not equal to 90 degree. None of the crystal axes are perpendicular to any of the other and repetitive intervals are different along all the 3 axes. ये आपको पाया जाता है सिंपल क्रिस्टल में पाया जा सकता है. ट्राइगोनल क्रिस्टल सिस्टम में A is equal to B is equal to C, alpha is equal to beta is equal to gamma नॉट इक्वल टू 90 डिग्री, मतलब अल्फा बीटा गामा तो सेम होता है लेकिन राइट एंगल नहीं होता। Three axes are equal in length, are equally inclined to each other at an angle other than 90 degree. ये ये भी मोस्टली सिंपल क्रिस्टल में पाया जा सकता है। द सेवेंथ वन इज हेक्सागोनल क्रिस्टल सिस्टम। इसमें क्या होता है, ए इज इक्वल टू बी नॉट इज इक्वल टू सी, alpha and beta is equal to 90 degree and gamma is equal to 120. Two of the crystal axes are 60 degree apart while the third is perpendicular to both of them. The reference interval is same, that are the part of 60 apart, but the interval along the third axis is different. और ये हेक्सागोनल लेटिस से भी हम सिंपल क्रिस्टल फॉर्म कर सकते हैं। ये सातों का बेसिक स्ट्रक्चर का क्रिस्टल डायग्राम है, जिसमें आप वो डिफरेंस देख सकते हैं और उन प्रॉपर्टीज को इस टेबल में समराइज किया गया है और साथ ही साथ एग्जाम्पल दिया गया है, क्यूबिक का क्या एग्जाम्पल है, किसका क्या एग्जाम्पल है। ठीक है ना, इसको आप लोग पढ़ लीजिएगा। इसके बाद नेक्स्ट टर्म आता है क्रिस्टल सिमेट्री, दैट इज सिमेट्री एलिमेंट इन अ क्रिस्टल। हालांकि सिमेट्री आप लोग के सिलेबस में नहीं है लेकिन थोड़ा सा जानना जरूरी है। Definite order arrangement of faces and edges of a crystal is known as crystal symmetry. A sense of symmetry is powerful for the study of internal structure of crystals. Crystal possess different symmetries or symmetry element. They are described by certain operation. Where symmetry है, then there will be symmetrical operation. A symmetry operation is one that leaves the crystal and its environment invariant. यानी वो जो सिमेट्री ऑपरेशन किसी भी क्रिस्टल में लगाया जाएगा, अगर वो वैलिड ऑपरेशन होगा तो क्रिस्टल और उसका एनवायरनमेंट इनवेरिएंट ऑफ दैट ऑपरेशन। System operation performed about a point or a point or a line are called the point group symmetry operation. Symmetry operation performed by translation as well as rotation are called the space group symmetry operation. A symmetry operation is transformation performed on the body which leave it unchanged and invariant. After performing an operation on the body, if the body becomes indistinguishable from its initial configuration, the body to possess a symmetry element to that particular operation. Three different type of point group symmetry elements होते हैं, especially center of symmetry और inversion center, reflection symmetry and rotation symmetry. सिमेट्री ऑपरेशन में चार चीजें होते हैं, आइदर ट्रांसलेशन और रोटेशन और रिफ्लेक्शन एंड इन्वर्सन। ट्रांसलेशन में क्या है, the translation symmetry follow from orderly arrangement of a lattice. It means the lattice point R under a lattice translation vector operation T gives the another point R prime which is exactly identical to R. Rotation में क्या होगा? A lattice is said to possess the rotation symmetry if rotation by an angle theta about an axis transform the lattice itself. Since the lattice always remains invariant by the rotation of 2 pi, that is 360 degree, the angle 2 pi must be an integral multiple of theta. So when theta is equal to 2 pi or theta is equal to 2 pi by n. The factor n take integral value and is known as multiplicity of rotation axis. The possible value of n are 1, 2, 3, 4 and 6 only. अब इसमें क्या है? For example, if n is equal to 6, theta is 60 degree. This means the lattice repeats itself with a minimum rotation of 60 degree. The value of n equal to 5 is forbidden. मतलब n equal to 5 is not allowed. Even n is equal to 7 is also not allowed. ये दिया 6 for rotation about point O in 2 dimension. तब अगला क्वेश्चन आता है कि 5 for root axis is not compatible with a lattice. मतलब n is equal to 5 जो है सो not compatible with the lattice. So let us consider a point A, B, C, D. Let T be the lattice translation vector. Let the lattice have n-fold rotation axis passing through the lattice point perpendicular to the plane of this surface. Rotation by an angle theta is equal to 2 pi by n about point B and C in clockwise and anti-clockwise. B को clockwise घुमाओ, C को anti-clockwise घुमाओ. It will yield B prime and C prime, which must be identical to point B and C. तभी तो ये सिमेट्री ऑपरेशन वैलिड होगा. Thus, B prime and C prime must also be a lattice point and should follow the lattice translation symmetry. Hence, B prime and C prime must have some integral multiple of BC. So, B prime C prime is equal to M into BC. और 2t cos theta is equal to t plus mt, जो कि रिड्यूस हो जाएगा थीटा इक्वल टू m minus 1 oblique 2, where m is an integer. अब हमारे पास क्या है? cos थीटा का जो वैल्यू है लेस देन और इक्वल टू 1 होता है. द अलाउड वैल्यू ऑफ m is 3210 minus 1. This corresponds to allowed value of theta as 0 degree, 360 degree, 60 degree, 90 degree, 120 degree and 180 degree. Hence the permissible values of n are 1, 6, 4, 3, 2. इससे क्लियर हो गया कि 5-fold rotation is not compatible with the lattice. Now let's come to the third, that is the reflection. A lattice is said to possess the reflection symmetry if there exists a plane. और 2 डायमेंशन में उस प्लेन को हम लोग लाइन में रिप्रेजेंट करते हैं. The lattice will divide it into two identical halves, which are the mirror image of the each other. Such a plane or line is represented by M. जैसे ये हमारा एक कोई चीज है जिसके बीच से हमने एक लाइन खींचा, ये प्लेन या प्लेन कट किया. This portion is mirror image of Considering the combination of reflection with allowed rotation. Each allowed rotation axis can be associated with two possibilities. One rotation with reflection and other rotation without reflection. मतलब रोटेशन दो तरह से हो सकता है, रोटेशन के साथ रिफ्लेक्शन भी हो या सिर्फ रोटेशन और रिफ्लेक्शन नहीं है. And the possible number of combination is 10, which is designated as 1, 1m, 2, 2mm, 3, 3m, 4, 4mm, 6, 6mm, where the numeral value represent the type of rotation axis. कितना rotation axis है? And the first M represent a plane or line parallel to the rotation axis. A second M refers to another plane line perpendicular to the rotation axis. क्योंकि एक rotation axis के उसके parallel भी एक line हो सकता है, उसके perpendicular भी एक line हो सकता है. तो first M represent the parallel and second M refers to this. उसमें जो फिगर पहले दिखाया गया उसके डिफरेंट पॉसिबल इमेजेस दिखाया जा रहा है इसमें. दिस इज द लास्ट स्लाइड एंड लो. Inversion is a point operation which is applicable to three-dimensional lattice only. Symmetry element implies that each point located at R relative to a lattice point has identical point located at minus R relative to the same lattice point. Inversion तभी होगा ना कि जहां पे है उसके नेगेटिव साइड में भी वो जाए तो रहे. In other words, the lattice possesses a center of inversion denoted by 1 bar. अभी ये 1 बार या 0 ये सब कहाँ से आता है ये आप लोग को जब मिलर इंडिसेस पढ़ाएंगे तब क्लियर होगा. Apart from this symmetry operation, a three-dimensional lattice may have the additional symmetry operations such as rotation, inversion operation.